Good morning to all. My name is Sandhya Rani, working as Assistant Professor in EC Department of Guntur Engineering College. Today I am going to discuss about basic building blocks of digital circuits. So the basic building blocks of digital circuits are logic gates. Why we are calling these logic gates as basic building blocks? We can manipulate binary data by using these logic gates. That's why these logic gates are considered as the basic building blocks of digital circuits. The, the there are three types of fundamental logic gates. So what are those? AND gate, OR gate, NOT gate. So let us see what is AND gate, OR gate, and NOT gate. So here AND gate. So AND gate is digital circuit that has two or more inputs and produces only one output. Then that digital circuit is considered as AND gate, and the output of this AND gate is logically and of all the inputs. So I will explain the what is the logical and of all the inputs. I will explain. So here is we have the truth table for this AND gate. I am taking the two inputs A and B and the output as Y. So if you give 0 0 input, it will give the 0 output. How this will truth table will be formed? I will explain. So the AND gate performs the logical multiplication, commonly known as AND function. So the operation of AND gate is such that high is only when all the inputs are high. When if you give the all the inputs are high, then only it will produces the high output. In remaining all cases, it will produce the zero outputs, that means low output. Here I'm giving the 0 0, so 0 0 no input is high, that's why zero output. Here I'm giving the 0 1, so here only one input is high, all the inputs are not high, so that's why output is 0. So 1 0 0, here 1 1 given, all the inputs are high, hence output becomes high. Let us see the working of this AND gate with its circuits. So see here, this is the AND gate circuit implementing with the two diodes D1 and D2, and I am giving the inputs A and B and output as Y. So if you give the A input 0 and B input 0, this makes the diode D1 forward biased and the diode D2 forward biased. So if this diode becomes forward biased, this diode behaves like a closed switch. Hence the supply will flow through this diode to the ground, and the output is does not reach to the output, hence the output becomes 0. So if any input is high and one input is low, then the corresponding diode will be on and the other diode will be off. So this makes the one of the diode is in conducting state, another diode is in non-conducting state. The diode which is in conducting state, the supply will flow through that diode to the ground, and this supply is not reached to the output, hence the output becomes low output. If you give the high inputs, both the inputs are high, then both the diodes D1 and D2 becomes reverse biased. So there is no path. Reverse bias means it will behave like you open switch. So there is no path to flow supply through these diodes. Hence that supply is flow through the load resistance to the output. Hence then only it will produces the high output. So the same thing is mentioned here. For 0 0 input, output is 0, that means low low. And if you give the 0 1 inputs, or 1 0 inputs, again output becomes 0. If you give A, and that means 1 1 input, output becomes high. So the next logic gate is OR gate. So this OR gate performs the logical addition operation. Commonly, that logical addition operation called as OR function. So the OR gate has two or more inputs and only one output. This OR gate produces the high output if any one of the input is high. If you give any one of the input is high, then it produces the high output. So the output is low when all the inputs are low. If all the inputs are only low, then only it produces the zero output. So if inputs of this OR gate is A and B, and then the output function, if you take it as Y, then the expression for mathematical expression for this output function Y is equal to A plus B. So if you take two inputs, then expression is like this. If you take more than two inputs, then the expression is going to be like this: A plus B plus C plus D, like that. Let us see the operation of this OR gate. I'm going to implement this OR gate with the two diodes like this. I'm giving the two inputs A, B and output Y. So through this output, I'm connecting the load resistor. If you give the zero input to A and B to 0, both the diodes will not contact, hence the output be 0. So if you give the 0 and 0, so these two diodes becomes reverse biased, then the diodes behaves like a open switch, hence it does not produce any output at the output, hence output becomes 0. If you give any one of the input is high, that means if you give A0 B1, then corresponding diode becomes high input diode becomes forward biased, low input diode becomes reverse biased. This forward voltage passes through this diode to the output, hence output will be high. If you give the low and high and low input, that means A1 B0, then D1 conducts and the supply, this current flows through this path and output reaches the high. So if you give the both the inputs are high, so both the diodes will be forward biased, and then both the diodes will be comes into the conduction state, which results in the output high. So the logic symbol for this OR gate is like this, and the truth table, I mentioned the truth table with the function of this functioning of this OR gate. For 0 0 0 0 1 or 1 0 or 1 1, it will produce as the high output. So coming to the next logic gate is NOR gate. So NOR gate basically, NOT gate basically performs the inversion or complementation operation. That means inversion or complementation operation. So that means this gate is used to convert one logic level into opposite level. So suppose if you give the 0, it produces the 1. If you give the 1, it produces the 0. So for this only it has the only one input and only one output. So if you give the high level input, it produces the low level output and vice versa. And the circuit diagram for this NOT gate, I am implementing this NOT gate by using bipolar junction transistor, that is BJT. If you give the high input to this transistor, what happens? Transistor comes into the on state, hence the supply will flow through this transistor to the ground, hence no output produced at this point, hence output becomes 0. The same thing mentioned here. For high input, it produces the low output. If you give the low input to this A to this transistor, so this transistor becomes open circuited, hence there is no path to flow supply through this transistor. Hence, the supply will flow through the resistor to the output. Then output becomes high. So for zero input, it will produces the high output. So the same thing is mentioned in the working. And the logic symbol for this NOT gate is like this. I hope you all understood this topic. Thank you. Thank you so much.